Excuse me, sir. I have a doubt regarding the project, the lab report that we have to do. My
Yes.
roll number is 200, sir, and it's asking us to put the register value as the last two digits of your roll number. So do I use 200 or do I use some other roll number?
Can you repeat? I could not get your question.
Yes, sir. My roll number is 200, and
Okay.
we have to put the register value as last two digits of the roll number.
Okay. That is, you are talking about electrical experiments, right?
Yes, sir. Yes, sir.
Okay. That actually you speak with the concerned faculty from electrical department, because I don't know what he said.
Oh, okay,
So
sir.
yeah, you have his mail ID, right? Just put a mail to
Yes, sir.
him. Yeah. So he will clarify that.
Okay, thank you, sir.
Mm. Okay. I think 20 student has joined. Yeah. Okay. So last class, what we discussed. So how many of you tried that MATLAB? I have posted one video, right? In the LMS, how to access the MATLAB through remote access. How many of you has gone through it and how many of you installed it? I mean, how many of you accessed MATLAB through remote access? Yes, anyone from this participant list? Yes, anyone? How many of you installed that softwares I mentioned, right? PuTTY and WinSCP to access MATLAB through remote server? Please respond. Now, what is that to respond? Yeah, I could see Payal is there. Teja is there. Yeah. Did you install Payal? These two softwares? Teja said no. Okay. What about others? I could not see anyone's name. So just please rename your roll number. I mean, your name is written as a roll number. So just rename your roll number with your name so that I can at least call you. Maybe in bracket you can write your roll number. Yes, Pranav, did you install these two softwares? So just to please watch that video I posted how to do that. Maybe because MATLAB is we have to purchase it, right? So in ICFI we have purchased, so you can access through remote server. Okay, that also how to connect it and all. I have shown that video. Please install that and practice it as much as possible. Because in this course, basically you are understanding the MATLAB program also, how to write basic things in MATLAB. And we discussed why MATLAB we are choosing, because MATLAB is right. Very many inbuilt functions you will see, it is available directly in the MATLAB. Instead of C, C++, Java, in that everything you have to write it from basics, right? But in MATLAB, many tools are available, by default. So just plug in and use that over. So that's why we choose MATLAB, and nowadays all maximum engineers, scientists uses MATLAB for the computation purpose. Very quickly, everything is done. Okay, so in the last class, we have discussed about the basics of MATLAB. We have seen simple operations, creating a functions and all. So in this class, we'll be starting with our first MATLAB based experiment, that is the computation of stresses on a body using a MATLAB. Okay, so why computation of stresses are required? So is my screen clear to everyone, or it is blur? Okay, it is blur. Fine. Just I'll share my screen. Yeah, I think now it will be better, right? Yeah, now it is better, right? Please, someone can confirm. Okay, fine, it is clear. Okay, so today we'll start our experiment 7, that is competition of stresses on a body using MATLAB. Basically, when we do that design of any structures, no, what do you mean by design? Design means like we find it out the beams dimensions, column dimensions, right? So you are sitting in a multi-story building maybe. So you will see there all around beams, columns will be passing, slabs will be there, right? So whether the beams and columns dimension is same for all the beams. You may find some beam will be wide, some beam will be narrow, right? In some other building, you will find, columns will be bigger columns, some will be smaller columns, right? So all these parameters. So finding out the dimension of beams and columns, we call it design of concrete structure, right? So before design of concrete structure, we do structural analysis. What is structural analysis? Means how loads will be affecting in a structure. For example, I am sitting on a building, right? So my load will be transferred from me to the slab where I am sitting. Now slabs are connected through beams all around. We have 4 beams, right? 4, 5, whatever the number of beams. So you imagine yourself, you may be sitting on a building, multi-story building, on a 7-story or 8-story, whatever it may be. So you are sitting on a chair, right? So your load will be first transferred through chair to the slab where you are sitting. Now slabs are resting on a 4 beams will be there, right? So your load is transferred from you to chair to slab to beams, and then from beams it goes to the columns, right? And from columns load transfers to the foundation or the footing, right, which is there at the bottom. So that's how the load transfers, and through foundation, the load is transferred to the nearby soils. So that's how the typical load transfer mechanism happens in any structure, either it may be building, bridge, whatever civil engineering structures you consider, right? In your car, where you are sitting, the loads are transferred through the wheels. So everywhere, the loads are transferred from, from one member to another member, and ultimately it, transfers to the soil. So that's how the typical load path, right? So now whenever the loads are applied on any structure, the stresses are generated. I think you guys have studied the stresses on your 11th or 12th standard, right? That I think 9, 10th also you've studied stress, strain, at least these 2 terms. And even in first year courses also you studied simple stress, compound stress, all these things. Okay. So anyway, we'll be deriving a small equation here, and then we'll try to implement it in the MATLAB. So that is our agenda for this experiment today. So stresses now you understood, right? Whenever loads are applied, definitely stresses will be generated on a structure. Okay, because the load has to be transferred, right, from one element to another element, and ultimately it reaches to the ground. So whenever loads are applied, there will be stresses. Okay, so I think everyone has I mean understand of what is stress. Stress, we in short form we call it sigma. You can see this one is sigma, which is nothing but a force by area, right? How much force, I mean, what is the total force acting on acting on this body divided by the total area, means cross sectional area. So that simple term we call it stress. Okay, so to design a structure, okay, design means, as I mentioned, it is to find it out the dimension of beams, columns, slabs, everything. So to find it out the dimensions, first we have to analyze the structure. Structural analysis has to be done. So if more stress is coming on a structure, so if more stresses are on a slab, that means you need more thick slab. Okay, for example, you are constructing a structure for a school building or a college university building. So in that case, many students will be coming, right? 60, 70, each class strength is 60, 70 students. Whereas if you construct a structure for, for apartment buildings or so, there each family member will be hardly, 5 to 6 maximum family members will be there. So in that case, a residential building, each room will carry maximum 5 to 6 members load. Whereas the same building, if it is used for the hospital or educational purpose, more number of people will be coming onto the room. So when the more number of people are coming, means more loads are induced on a structure, means the more strength, I mean, more stresses are induced on a structure. That means you need, I mean, wide, thick beams, thick columns, thick slabs, all these things. So that's how. So the dimension of beams, columns, all these things are actually derived based on the how much loads are coming on a structure. If more loads are coming, means the slab thickness and everything will be more. If the less loads are coming, then these dimensions also will be less. Okay. So that's why we need to do the structural analysis. Before constructing a structure, we have to perform the structural analysis. So in that structural analysis, what we do, we find it out: the stresses, strains, shear force, bending moment, all these things I think you guys have studied in the first year, or second year also you have few courses on that. So stress, strain, bending moment diagrams, shear force diagrams, all these things we typically draw, and based on that we design our structures. Okay, so in this class or in this experiment, basically we'll write a simple MATLAB code uh, to compute the stresses on a structure. Okay, so stresses, now you understood, it is simply force by cross-sectional area, we call it stress. So this is the sigma, you can see, force by area. So I'll go very quickly here because these concepts you know, I'll give more time on the coding purpose. So you can see this is a body. Okay, if you can see a rectangular block and two forces are acting, maybe one person is pulling from this side, another person is pulling from this side. You can imagine this is simply a box or something where two-person is pulling in two sides. So, and both the person are pulling in the same force, P. This portion also P and this side also P. That means, the body is subjected to a load of P, which is at X direction. So if you see, this is the X direction we are talking, right? So let me draw it here. So, yeah. So now you can see this is the X direction, and X direction P load is acting on this body. Okay. So now if you are finding out what is the stress at this plane, EF. So EF is a plane, right? EF. So what is the stress in this plane? So stress definition already you know. Stress is what? Force by simply area of EF. So area of EF, maybe you can consider it as A. Okay, and stress, so simply force is P acting by cross-section area is A. So very simple. So stress is sigma at the rate EF, means I am talking about this plane. Okay, so this plane, it is simply P by A, as you know, very simple. So now if I take another plane, which is EF, now sorry, which is FG. So this is the inclined plane, which is at an angle of 30 degree, which is, I mean, any angle, maybe it may be here theta. Okay, so if a plane is here, FG, and if I ask you what is the stresses at this plane, maybe in the same direction, we are talking this direction, what is the stress? Stress at the X direction. So this is X dimension, right? This is X and vertical is Y. And we have third dimension, simply that is Z. Okay, so what is the stress at the X direction? So now the plane has changed. Earlier the plane was vertical one, EF, and this is the stress, simple P by A. But if the plane is inclined plane, which angle of theta, then what will be the stress in this direction? So can anyone tell me? Sigma X will be how much? Sigma X will be force is anyway P, right? In this X direction, how much force is acting? It is P, constant. So we are not changing the force P here. But whereas the area, I mean, area earlier it was EF, which is just perpendicular. Now I just made it to rectangle, I mean the inclined area, which is angle of theta. So now area will be how much? Earlier it was A, and this is the cos component, right? You studied in physics also. So this will be A cos theta. So force by area. So now this is your sigma X. So from here also you can simplify what is P by A. P by A is nothing but our main earlier sigma. Sigma. Okay. So sorry. Let me clear it out here. Yeah. So that's what we are discussing, right? Area will be simply EF. EF is nothing but A we consider, right? This area is A we consider. So A by cos theta is a inclined area. Okay. And the stress will be what? Force by area. Okay. So stress will be force by area. Just it will be by cos theta, right? So just make that correction. So this is the correct one. So EF by cos theta is the inclined plane area. So this plane, it will be EF by cos theta, not multiplied by cos theta, just to make the correction. So from this simple triangle, right, we derived it. So if you take this triangle, small triangle, EFG, Okay, so in EFG, what is cos theta? Cos theta will be base by hypotenuse, right? Base is how much? EF. So EF by hypotenuse is GF, right? So FG, which is nothing but cos theta. So from here you can find it out what is GF. GF is nothing but EF by cos theta. So the area now, this inclined area is EF by cos theta. Okay, so EF is, we consider it a cross-sectional area A. So A by cos theta. So this is a inclined area. So now stress is what? Force by area, right? Force is P, it is same, not changed. Whereas area is now A by cos theta. So you just replace it, just cos theta will come up. So P by A cos theta. So P by A is already, we know, this is stress sigma. So it is just sigma cos theta. So the stress on this section, GF, so this section is nothing but sigma cos theta. Okay, so these two formulas, we'll just write it out in the MATLAB. So this is one part. So is that in up to that point, anyone has anything to ask? So we derived one formula, sigma cos theta. So we'll try to do it in MATLAB. So this is one part. And another is stresses on inclined plane. So what just now, whatever we computed. So this one we computed the stresses at the direction of X, right? Now we have actually two types of stress. One is normal stress. I think you studied this. Normal stress, and another is shear stress, right? These two types of stresses are there. Already you have studied. What is normal stress? So perpendicular stress perpendicular to the section, we call it normal stress. Whereas stress along with the section, we call it, along with the axis, we call it shear stress. So in the next slide, we'll be calculating the normal stress and the shear stress. So the same example I have considered. So load is acting P here. So now in this inclined plane, GF, so earlier we computed this axis. At axis X, what was the stress? Which we got it? Sigma cos theta, right? So sigma cos theta is basically towards the X direction. But as per our normal stress means what? Which will be perpendicular to the section, right? So our section is this one, GF. So which perpendicular is which axis? So this axis is the perpendicular, right? So perpendicular to that GF is this one. So this is actually normal stress. So normal stress, we denote it sigma suffix n. Sigma suffix n is the normal stress, this one. Earlier we computed towards the X direction. This one we computed. Now we are computing sigma n, that is normal direction. And what is shear? Shear means if you are computing a stress along the axis. So this is our section, right? So along the section, if you compute, what is the stress? Along the EF, along the GF, along this axis, that we call it shear stress or the tangential stress. Okay, so these two parameters, now we are finding out the equations. One is normal stress, which is nothing but a perpendicular to the axis, perpendicular to the section, and the shear stress, which is nothing but the all along the section, that stress we call it. So sigma shear stress, we denote it sigma T, whereas normal stress, we denote it sigma N. Okay, so the stress definition is same. You have to find it out what is the force by area, right? That is our by default definition. So force by area. So now first let's compute the normal stress. So normal stress is how much? So in this direction, you have how much area? Area already we computed, right? A by cos theta. In the last slide, if you see, area we computed, that is inclined area is A by cos theta is the inclined area, right? So this area portion is fixed now, we know, A by cos theta. Now P is acting as towards X direction, right? So now we have to convert P into towards this direction, angle. So this angle is theta. So now towards this direction, how much P is acting? So P is acting towards X is P. Now how much is acting towards this direction? That we are finding out. So that is nothing but P cos theta. So towards x-axis it is P. Now if this angle makes theta degree, right? So theta means P cos theta, towards this direction it is force is acting. So P cos theta by area. Now if you simplify it, you will get it sigma cos square theta or P by A cos square theta. So this is the normal stress in an inclined plane. So this is an inclined plane, right? Similarly, if you find it out that shear stress, the shear stress is towards the axis, how much, I mean towards the section, how much force is acting. So P is acting towards X direction, right? So now this is the all along the axis, so same axis GF. So this will be P sin theta. Very simple, right? Two components, if you derive it. So one is towards perpendicular axis, which is nothing but P cos theta, and towards the section plane, that is P sine theta. You studied, right, all these things from the physics. So just area is same, P by cos theta, but the force is now P sine theta. Now if you simplify it, you will get it something like that, P by A sine theta by sine theta cos theta. So this is our final formula. So now these two formulas we have derived. Now we'll try to write a code to make this process automated. Okay, so anyone has anything to ask up to this point? So these two formulas derivation, anyone has any confusion? No, right? Okay, so now let's go to MATLAB and we'll simply write a simple code. Okay, so I already explained you how to use remote access for the MATLAB. So anyway, I am using this environment. I'm in the online MATLAB. So it also need a username and password, but we don't have license for that. But the remote access I have shared with you. From that you can write the MATLAB code. Okay, so it is opening. So first we'll write the simple code, that is the simple stress code. Okay. It is still loading. Yeah, while it is loading, anyone has anything to ask? No. Okay. Now you can see the MATLAB has loaded in our browser. So similarly, when you install the MATLAB in your computer, this is the GUI of the MATLAB. Okay, but I explained you in the video how to use the remote access, where you can't see the GUI like that, but you have to use only the command window, this arrow, right? If you see, with this command window, you have to write the MATLAB code in the remote server. Okay. Yeah, so it is still loading. Yeah, now it is loaded. Okay, so first make sure that which folder you are in. So currently I am in my MATLAB drive. Some folder is there. In that folder I am here. So all the files and all everything you will get it in that folder. As I mentioned, this is your current folder, means which folder you are logged in. And similarly, this bottom part is workspace, where all the variables and all will be stored inside the workspace. Okay, but in your case, if you are using through that remote access, where you can't see maybe the workspace, you can't see all the outputs, you have to print it in the command window. Okay, so now we'll start writing a script, small script. So in that, our first process is to write the simple stress calculation, right? So I'll open a new script. So at the top side, if you see the new script, so similarly for your case, it will be, you have to create a new file with the extension .m. So I have explained how to do that also using that Notepad++. For the Windows user, you have to install this Notepad++ software, and where you can write the code. Okay, so at the beginning, you do not need to write anything like C. You are writing right hash include stdi or .h. Okay, something like that. But here in MATLAB, no need to write anything. Directly, you can write your code. So for example, load. Okay, so load is a variable. Okay, so let me give some load value as a 1000 maybe unit you can give. So if you write semicolon and then whatever you write, that will be commented. So while executing the code, this after this percentage symbol, whatever you write it, it won't be evaluated. Okay, so any comments, anything you can write it out. Just in case of C also, if you remember, you use slashes, right? Once you write slash, the remaining part is not evaluated. So, but in MATLAB, here it is percentage. So unit is maybe unit is Newton. So anything you can write it after this percentage, this line won't be evaluated by the MATLAB. Okay, so whatever is that. So I have just created a variable load, and I have assigned the value of 1000, and the unit I just wrote it as a commented person. Now rectangle, maybe we are considering a rectangular body, right, in the example also. So maybe rectangular area a means one side, or maybe width I'll write. Rectangular underscore width will be, for example, 5. The unit maybe in centimeter. Okay, unit in cm, centimeter. Okay, similarly now rectangular, sorry, yeah, rectangular width and now height or something is 6. Okay, so here see, unlike C programming, you have to initialize the variable at the beginning. If you remember, you used int int a comma b, all the variables you were initializing at the top. But here directly we are assigning the values. Okay, so now just now we have created the 3 variable. One is load, and we have assigned the values also, 1000 rectangular area. Now if you want to find it out the stress, so stress is nothing but force by area, right? So force is load by cross-sectional area. So simple, very simple thing. Cross-sectional area by W into rectangle. So area is what? Width into height, right? So rectangular underscore height. Yeah. So now our first simple stress calculation is over now. Now if you save it, so just given any name of stress 1. Okay. Yeah. So now I just saved it. Now you can execute it. This run option is there. But in your case, how to do that from remote access, that also I have explained in the video. So just click on run. So the stress 1 will be executed. But if you see the output, no output came. Why? Because the stress we just commented, right? Semicolon we have given. That means whatever values are there, stress, it won't be displayed at the command window. But if you see in the left hand side workspace, all the variables are created. So what was our first variable was load, which is nothing but 1000. The value also you can see. Similarly, rectangular height also 6, rectangular width 5, and then the stress also it computed 33.33 Newton per centimeter square isn't stress. But in the command window you can see. But if you access through the remote access, whatever I explained in the earlier video, so there you have to print the output here in the command window itself. So in that case, you just make it open. So don't use semicolon. Semicolon means the output won't be displayed in the command window. But if you don't give semicolon, the output will be displayed in the command window. So in that case, again, you type the file name. File name is what? Stress 1, right? Stress 1, and give enter. So yeah, I think I have not saved that. Yeah. Yeah, now you can see the output has came here. So I'll just drag it down up. So now I just removed the semicolon. So stress, it is showing 33.33. So in your case, you may not see the workspace because in remote access, this is not possible to watch. But you can print it. Whatever values are there, you just type it here. Stress is a variable, right? It will print the stress. Similarly, if you want to print the load, so just type it load, it will print whatever is the value stored in the workspace. Okay, so like that you can see the work window. So very simple program we have written where the load and the cross-sectional area we have given, and our code gives the stress. Okay, now you can ask, right, every time if I want to do another calculation, like load is now 2000, load increased, but cross-sectional area is same. But again, we have to change the code, right? So every time the repeated work, if you are doing, then instead of modifying the code, you can write a function similar to the C programming or JavaScript, whatever you have studied in the first year computer programming course. So you used functions, right? Functions, if you do any repeated works, we can use simple functions to do that. Okay, so here also in MATLAB also we can create a function for any repeated works. For example, the same problem here. So instead of putting everything, we can simply write a function here. So how to modify that? So to write the function, the syntax here is you have to write function, 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 then give a space, and then we want to compute stress. Okay, stress equal to, give a function name. Function name may be simple stress. Okay, simple underscore stress. So I'm creating a function with simple stress. Then in bracket, you write load, because load will be changing. Similarly, if you want cross-sectional area also has to be changed, then these also you keep it here. And rectangular height also, comma, rectangular height. So now I'll just comment it, or I'll remove these 3 lines. Okay. So yeah, so I'll just comment it out. So I have written a very simple function, which is stress equal to simple stress load. So what are the inputs? It is taking load and the width and the height. Okay, so this is height. So yeah, this is height, correct. So very simple function we have written, right? Now we have to save this function. So make sure that while saving the function, see here some error you will get it, because the file name is stress1, right? But the function name is simple stress. So the file name for the function also should be same as a simple stress. So I'll go to my directory where I have saved stress1. So you can see where is stress1. Yeah, so this is the stress1. So I have to rename it, because now I am writing the function. So function file name also should be the function name. So function name is simple stress. So I have to rename this file name with a simple stress. Okay. Yeah, now I have renamed it to a simple stress, you can see. So now now if I want to write it, 1 second. Yeah. So now I just use this function. So stress, yeah, stress equal to simple stress. Just now we have written a small function. Let me copy it here. Simple stress. Now here you give the values directly. Maybe 100. So any rectangular value you can give here. A rectangular area value, 45 may be the cross-sectional width, and the height may be 30. Okay, so just give enter. So it will compute and it will give you what is the stress. Now, if you want one more calculation, so one more calculation means just write the same, directly write the code and change the value. Okay, maybe 110, just any random value I'm checking with 3. Okay, so I need not to change my code. So our code is, I am not changing anything. I am just changing the input value. So this is the input value which we are giving. So that's what the advantage using the function. So in any value, just assign the input value, it will give you the output. Okay, so just make sure that you create this type of small functions. So function, you have to write the function and what operation you want, the function name, and what is the input value it is asking for, and then the output. Okay, and make sure that you save the file with the same the function name. So the file name also should be simple underscore stress.m. Okay, so now this is the simple problem we have run. Now, if you recall, we have discussed that inclined plane, right? Inclined plane, what is the stress? So this one, if you see the first case now. So we have this inclined plane of GF. Then what is the formula here? The formula here, stress is P by A into cos theta also came, right? Theta is the angle. So very simple to quote that. So here, one more input you need, right? That input is what? Angle. Angle is degree. Just give any name in your. So here I just added one more term, degree, because now we are finding out the stresses of the inclined plane. So now stresses will be how much? So what is the formula? If you see, formula is P by A cos theta. Okay, P by A cos theta. So we are just modifying the earlier code only. So stresses will be P by A multiplied by cos theta, right? So this multiplied by cos theta. So in MATLAB, just write cos. it will take care about the cos. Okay, but if you write now cos degree, TGREE. Okay, so now we just modified our code. So now the stress will be stresses on the inclined plane. What we did, load cos degree. Now if you write simple cos, means MATLAB understand whatever you are writing inside that, that is in radian, not in degree. For example, you want to find out cos 30 or sine 30. Let me write it here and show it to you. So if you write sine 30, what is the value of sine 30? Can anyone tell me? So sine 30, if you write like that, MATLAB will understand whatever is there inside that, that is not in degree. By default, it will be in the radian. Okay, so now if you give enter, so cos 30, you know half, right? Cos 30 degree, but it is showing some other value, minus something 0.98. So because the MATLAB has considered this is in radian. So if you want to put in degree, then you have to put sine D. So D for degree. So just now you put 30 and press enter. So now it will show you half 0.5. Okay. So why if you are entering the angle in degree, then you have to write it out sine D or cos D, whatever is there. So here we are in our example, we are putting it in degree. So let's put it cos D. D means degree we are giving the answer. I mean the input. And this is the code. So now we just modified the code, save it, and then you execute it. Okay. So this is the input file we have to give it. I mean the input command. So let's not change other parameters. Yeah. So the load now maybe for example 100, cross sectional width 5, 6, and the angle now if I give 30. So at 30-degree inclined angle, what is the stress? So this value it will give you at 30-degree angle, what is the stress? So this is 2.68. Okay. So now see now our function will take 4 value: load, cross-sectional area, and the angle also. Now if you miss any one parameter, so for example, I just remove the degree, and if I enter, so it will give us error message. Why? Because not enough input arguments, because input argument it takes 4 now, but we just remove the degree. That's why it will give you error. So you have to give. And in MATLAB, there is an advantage using MATLAB. See the debug information also. So in code while writing, you will do so not so many mistakes. So MATLAB will give you enough clue where you have done some mistake. So that's why I see MATLAB is telling not enough input arguments. Means the simple stress takes 4 value, right? Load, rectangular W, H, and degree. But here we are giving only 3. That's why the error message comes. Okay. So like that, you can just simply modify. Now you understood, right? How to do that, this part also. Now we'll go to quickly. Okay, let me plot it one more thing. Now, if the degree we just here it is simple static degree, we just use 30-degree, 40-degree, whatever it may be. Now if you want to plot it, maybe if degree is changing from 0 to 360-degree, means this angle, now I want to plot a stress which is now varying. So at the beginning theta is 0, now gradually theta is increasing, theta is 1, 2, 3, 4, like that after 360-degree theta. How much stress is changing, that you want to see now. Okay, this inclined angle, if you want to change it from 0 to 360-degree, how the stresses are changing, that you want to plot it or you want to see it. So in that case, how to do that? So let me write a quick function, I mean quick program here to do that. So now I am writing a script, not a function. So I'll be using the earlier function in the script itself. So in MATLAB, see the already in our workspace, if you see so many variables are already there. So now I want to remove all the earlier variables because it may interfere in our present calculation. So in the MATLAB, the command called clear. So it will clear all the variables, all the workspace, it will be empty now. After you execute clear command, it will clear all the workspace variables. Okay. So now we want to plot something. Maybe for example, now load is fixed. Let me write it maybe 100. And okay, we'll just copy this part. No problem. System is slow. Okay. So now rectangular W also maybe some constant value we give it 5. Okay. And rectangular uh, height is also you give some random value of 4. Okay, so now our cross section is ready. I mean, the material has the block has a width of 5 centimeter, height of 4 centimeter, and the load is acting 100 kilonewton, 100 Newton. Okay, so now we want to find it out if the inclined plane. So this is the inclined plane, right? This is the inclined plane. So if this inclined plane is moving from 0 to 360-degree, then how the stresses are changing? That is our objective, to find it out. Okay, so now we'll go to MATLAB again. And now we want to compute the stresses. So let's create a degree now. So here degree is not static because we want multiple degree, right? So degree is equal to, I have shown to you in the last lecture also how to create the multiple array of degrees. So a multiple array of values. So now I am creating a variable or matrix degree, which first value is 0, increment is 1, and it goes up to 360-degree, 360. Okay. So now I have created a variable degree, basically a matrix it is. The first value is 0 and increment to 1 means first value 0, second value 1, third value 2, 4, 5, 6, like that it will go up to 360. So now degree is now a matrix. Okay. And now we need a for loop for the MATLAB because our interest is the same function. So whatever we have written, right? Sorry. Okay. Some internet connectivity issue. Okay, so now our degree is changing, right? 0 to 360-degree, whereas other parameters are same. Load, width, height, all these parameters are same. But the degree is changing. So earlier function, whatever we have written, that function needs to be executed 360 times, right? In the first time, you put degree equal to 0. Now in the next iteration, you put degree equal to 1. In the next iteration, you put degree equal to 2. Like that, our entire loop or entire function should be run up to 360 times with 360 different values. Okay, so that we are doing it in the for loop. So that we are writing. I think the internet connection got restarted. That's why the MATLAB is also again restarting. So yeah, it will be fast. So basically here now we are writing a for loop. So to run the same command multiple times with multiple input values, we use normally for loop, right? So that I'll quickly show it to you. Yeah. So the homework or the assignment I'll put it is the second problem. So this problem, simple problem I just explained step by step everything with for loop. Now I'll post it in the LMS. The assignment for you guys to write a code for this problem, second problem. That means in the first problem, basically we find it out the stresses towards x-axis, right? But in the second problem, we are finding out normal stress and the shear stress towards the perpendicular from the section and along the section. So shear stress and normal stress. So this will be your assignment. I'll be posting it in the LMS. You have to write a code, okay, and you have to execute it. So if you copy, I'll ask in the class, right? Everyone I'll ask how to explain the code. So don't copy, just understand how to do that. Okay. Yeah, still it is loading. Yeah, it will open. I hope it will open the script, whichever we have written last time. Yeah. So this program we have written, right? Okay. So we started another new program that is for the multiple values. That is, we have not saved it, right? That's why it got crashed. So anyway, we'll do it clear. We'll do it quickly. So our first command will be clear, means we are clearing any earlier workspace variables. And then we have the load is fixed, which is 100. This is one line. I'll quickly complete this. And then rectangular width is 5, and rectangular height is maybe 8 something. Okay, so now we want to create a degree, so a variable degree which will be starting with 0 to increment 1, it goes up to 360 degree we want. Okay, and now we are writing the for loop. So for I equal to similar syntax, whatever you did. I is equal to 1, 2 means our program should run from up to how much? From I equal to 1 means first loop to the total, how many members are there, right? In the degree. So in MATLAB, the command is length. So length degree. Again, there is issue. Yeah, now you can see, right? The MATLAB program, it is just quickly over. So now degree we just created, it is 1 to 360 degree and load is constant. Similarly, the rectangular B is 5, rectangular width is 6. Now we return a for loop. So for loop for equal to 1 to length of degree. Length of degree means total how many members are there. And the stress, we are creating a stress and we are using the function. Last slide, if you remember, we just created this function, stress of inclined member, and degree we are considering in each loop basically 1 I value. So at the first loop I is equal to 1, right? At the first loop I is equal to 1, so degree first member, so in the degree. So once you execute, if you see the degree variable how it created, so it is 0 1 2